phase induction motor or three-phase induction motor. What we have seen there are two types of induction motor depending upon rotor construction. One is called as squirrel cage induction motor, another one is called as wound rotor induction motor. So both motor are having different features depending upon its rotor construction. So let us first see what are the features in case of squirrel cage induction motor. So the first feature, we know that its construction is rugged, robust construction is there, rugged construction is there. So it is a feature. Simplicity in construction, that is again simple motor it is, you could say. Cost is low cost and low maintenance charges. So these are certain features. So depending upon this feature, you can identify its application where it can be deployed or it can be used. Okay, so particularly this particular motor could be used depending upon its feature. We know that it has low starting torque. At the torque that will depend upon, it can be decided while this motor is manufacturing. So at the time of designing of this motor, its starting torque will be decided, and that will depend upon the value of rotor resistance. In case of slip ring induction motor or wound rotor induction motor, we have seen when external resistance was added, so the starting torque was getting improved. In this case, squirrel cage induction motor, external resistance cannot be added, it cannot be inserted, so that during designing the value of resistance is, rotor resistance is going to be fixed. So depending upon that, basically its starting torque, when you are going to compare with slip ring induction motor, it would be less. So its application would be in those places where the requirement of low starting torque is there. The load requires low starting torque. In such application, you can use squirrel cage induction motor. Other thing, where you require a constant speed, for such application, preferable motor is squirrel cage induction motor. As we were talking about, its resistance, rotor resistance, will be decided during time of designing. So you can design basically two types of motor, squirrel cage induction motor, where resistance you can keep low, and for another design you can keep a high value of resistance. So somewhere you must balance it. What should be the value of resistance? Whether it should be extremely low, so starting torque that would be very poor. If it is very high, so starting torque could be quite high. But you need to basically consider an optimum value which do not affect its running operation of squirrel cage induction motor. Because if the resistance is very high and it is going to remain in the circuit, so it is going to affect the operation, running operation of squirrel cage induction motor. So somewhere you need to compromise. How much starting torque is required? Accordingly, the rotor resistance should be considered. So here we are considering two cases where a squirrel cage induction motor with low resistance is designed. So what would happen? It is going to give you low starting torque and running performance that would be better. So that its application you can use in fans, centrifugal pumps, machinery tools, woodworking tools, etc. When you are designing squirrel cage induction motor with high value of rotor resistance. So you could improve starting torque, you are going to get better starting condition, but it is going to deteriorate. There will be poor running performance, or the performance that will be deteriorated if high value of rotor resistance is considered during the design phase. So considering this, you could also select the slip when the full load slip is in between 3 to 7%. At that time, this motor could be selected for compressor, crushers, reciprocating pumps, etc. on similar line where the slip is between 3 to 7%. It may have possible applications for intermittent loads which will be having slip in the range of 7 to 16%. Full load slip we are talking about. If that is in the range of 7 to 16%, so at that time the motor could be utilized for shears, hoists, elevators, punching presses. Intermittent load requirement increases, then it decreases for certain times. You could think about punching presses. When you are punching, at that time the requirement would be more. When the punching is over, you are going to release, so there will be no load. So the load is intermittent. It increases and decreases, increases, decreases. Like your elevators, empty elevators and loaded elevators. So you could understand, I think. So basically what we understood, whenever we are going to talk about the application of squirrel cage induction motor, we must think about the rotor resistance value. If rotor resistance value is low, at that time you could deploy that particular motor where starting torque requirement is low, and you need better performance, operating performance better. If you require, you can compromise with low starting torque factor, poor torque factor. The performance would be great. But for certain load where requirement of starting torque is high, at that time rotor resistance should have a higher value. But what would be its consequence? Starting, it's okay, it is going to pick up the load, but the running performance, that will be deteriorated. So considering this, you could use a particular squirrel cage induction motor. You can deploy for these applications. There could be more applications, few are shown here just for understanding. And even when you are using high rotor resistance, at that time you must consider the slip. What is the range of the slip? Whether it is up to 3 to 7% or it is up to greater than 7%, 7 to 16%. So that must be considered, and accordingly the squirrel cage induction motor could be selected. But the best choice in general, it will be the load which requires low starting torque and sustainably constant speed. Now let us move on. Wound rotor induction motor. Wound rotor induction motor, when we know squirrel cage induction motor, so obviously you could think about wound rotor induction motor. Wound rotor induction motor, you can vary starting torque. You do not need to worry about that, okay, what would be the running performance. Add rotor resistance, insert external resistance to rotor circuit, it is going to improve starting torque. You can remove it later on. So this particular motor should be deployed where high value of starting torque is required, because you can add on resistance. And the second thing, speed control where it is required. There constant speed. Here speed control. You can change the value of rotor resistance by certain means, and external resistance can be changed you can vary the speed. So speed control can be obtained. So depending upon this, some of the applications, it can be used in hoist, elevators, compressors, cranes, etc. When we are going to compare two motors, wound rotor induction motor and squirrel cage induction motor, already we have seen the cost is less in case of SCIM. Here cost is high, maintenance is high. The reason is brushes, slip is there. That you should keep it in mind. So let us talk about advantages of squirrel cage induction motor over slip ring induction motor or wound rotor induction motor. See, whenever we compare, always consider the same power rating. Then only you could talk about what is the advantage and what could be the disadvantage. Do not compare two unequal things. Okay, so cage motor, when we will talk about in terms of efficiency, it is going to give you better efficiency than wound rotor motor of same power rating. How efficiency would be high? Losses would be low. Losses would be less. The losses, I square R losses, that is less in cage rotor induction motor because it requires less conductor compared to wound rotor induction motor. Slip ring induction motor, because it consists of slip, it would be costly. Brushes are there, it would be costly. Short circuit devices are required. That's why it is going to increase its cost. SCIM is cheaper. An induction motor, a cage induction motor, it has more pull-out torque, greater high value of maximum power output, and better operating power factor when compared to wound rotor induction motor. The reason is the diameter of circle diagram. The diameter of circle diagram for a cage rotor, it is more than the diameter of circle diagram of wound rotor induction motor of same rating. See, same power rating we are considering here. So in that case, the diameter of circle diagram, that would be higher. It will takes a high value, a large value than slip ring induction motor. So what would happen? This would result due to, you could say, the leakage reactance that is low for a cage rotor due to very small length of overhang. So X2 will play a role here. Due to construction of, due to, you can say, a rugged construction of squirrel cage induction motor, maintenance requirement would be less. Slip ring induction motor, brushes, slips are there, so requirement maintenance would be more. The cooling, it would be better in case of cage rotor because of its bare hand rings. If we talk about disadvantages, so problem is with poor starting power factor. The second thing is small starting torque and high value of starting current. That is a problem and disadvantage when we are comparing two motors. So this will clear you, this will give you a clear idea when you are selecting or when you have to select, choose a motor for a particular application between these two. These things you should keep it in your mind. The cost, it is going to matter. Efficiency, it is going to matter. The requirement of torque, speed control, that is going to matter. So depending upon that, application can be decided particular motor can be decided for a certain application. There are certain points. We are end of this module. We have completed induction motor. So few things we should remember regarding induction motor, that it is a self-starting motor. It has inherent starting. You do not need any external means to start it. The requirement of starter is something different, which we are going to cover in next module. Starter is going to reduce the starting current, or it is going to limit the starting current in order to damage the induction motor, to protect it from damage of induction motor. So it has self-starting torque. It start its own. Just connect three-phase supply to the stator, it will start running. The rotor that will start revolving. Other thing, when there is increase in load, its speed is going to decrease. It is going to fall. It cannot achieve synchronous speed. That's why it is called as asynchronous motor. Synchronous machines are those machines which operates at synchronous speed, 120 F by P. You can determine using this formula synchronous speed. So it can never achieve synchronous speed. When you connect AC supply to the stator of three-phase induction motor, it starts operating. You not need to provide excitation separately, and it does not require DC excitation. Therefore, it is a singly excited motor. Single excitation, it can work. No DC excitation is required. If you would notice, this motor is going to operate at only lagging power factor. Only at lagging power factor. We have seen by adding rotor resistance to the rotor circuit, it is possible to control the speed. Squirrel cage induction motor speed is also possible. That is also possible. We are going to see next module. It can be used to supply only mechanical load. Otherwise, if you want to supply to electrical load, so again you need to convert mechanical power to electrical power. Then only it can be supplied. Motor we are talking about. Its maximum torque is proportional to square of the supply voltage. So supply voltage you can vary, so its maximum torque is going to be varied, not starting torque. We are talking about maximum torque. Induction motor which are having speed above 500 rpm and rating below 120 kilowatt, they are cheaper than synchronous motor. So these are few points which you could keep it in your mind regarding induction motor. So here we declare the module is over.